Hello, everyone. So rather than upload the lecture that I gave earlier today, I decided to actually pre-record these slides. That way, those folks who need to see the slides as I'm talking, you're able to do that while following along in this presentation. If you have any questions, issues as far as hearing me, please let me know. That way I can redo the presentation, but otherwise we are going to get started. Because we only focused on pH today, that's all I'm going to share during this lecture. Next week we will talk about salinity. So let's get started. Okay, so what is pH? pH measures the concentration of hydrogen or hydroxide ions that are in water. So if you see here on our molecule that we're looking at here, this is showing that when you have a water molecule such as this, that water molecule does not just exist as water or H2O as we're normally used to thinking about water. It actually exists in three states that are all happening at the same rate. And you'll see why I say it that way in a second. So you'll notice that here it breaks apart. You have your hydroxide ion, which is what you're seeing right here. And you also have your hydrogen or proton, which is what you're seeing here. In addition to that, what I did not include, because it doesn't happen quite as often, is that you could also have what's called a hydronium ion. And you'll notice with this hydronium ion that there are 1, 2, 3 hydrogens. All has to do with the number of hydrogens that are attached to this oxygen. Now, the reason that these atoms or molecules exist this way in water is because of this concept right here, dynamic equilibrium. So essentially what that means is that when you have all three, or all four rather, of these molecules, they're all kind of switching back and forth at the same time. The water is breaking apart. One of those hydrogen ions or atoms is breaking apart. That forms the hydroxide and the hydrogen atom. And then if this hydrogen atom is near another water molecule, which is what you're seeing right here, then it can form the hydronium ion. This is all happening at the same time. It's also happening at the same speed. So when we're talking about dynamic equilibrium, that's the speed that hydrogen and hydroxide, or OH, forms water at the same speed. So as you can see here, the pH goes from 0 all the way to 14. And what this is basically sharing is how many hydrogen atoms there are compared to hydroxide atoms, or OH atoms. So for example, if we are looking at the pH of 7, that means that the amount of hydrogen atoms is equal to the amount of hydroxide atoms. So therefore, if we look on this pH scale, the amount of base is equal to the amount of acid, which is what you're seeing here. Now, if we move on to acid, what you'll notice is that here, the amount of hydroxide, or hydrogen rather, atoms is greater than the amount of hydroxide atoms. It seems very counterintuitive considering that the pH on this side here is smaller. Remember that we are working with a logarithmic scale. So therefore, just think of these numbers as the opposite of what you'd normally think. So if the numbers are going down, that means the amount of hydrogen atoms is going up. And the opposite is true on this side. If the hydrogen atoms are going up, or the hydroxide atoms are going up, then the hydrogen atoms are going down. So in this case, when you're talking about an acid here, the pH is less than 7, and that's what makes up the acid. Also keep in mind that I'm using the Bronsted-Lowry version of acids and bases. You will learn other versions of what makes an acid and what makes a base, but for our purposes, it only has to do with the amount of hydrogen and hydroxide atoms. And finally, we have our base, and it's the exact opposite of an acid, as you know. It means that there are more hydroxide atoms or molecules than there are hydrogen atoms. So because of that, we have the reverse here, where the numbers are going up. The numbers are going up because the amount of hydrogen is going down. This is all based on the amount of hydrogen atoms. So therefore the pH is higher. So an example I used during the lecture were things like acetic acid, which is also vinegar, hydrochloric acid, which is in our stomach. We have felt this acid before if you have had heartburn, or if you've eaten something that's really acidic or eaten a lot of it and it kind of backs up into your throat and you feel that burning sensation. That is why people take antacids. It is to neutralize that acidity that is in your stomach and is backing up into your throat, and you can sometimes have heartburn from that. You're adding a base to neutralize that acid.